So here is question number 31. The combination of two bar magnets making 20 oscillations per minute in an oscillation magnetometer when like poles are tied together and 5 oscillations per minute when unlike poles are tied together. The ratio of magnetic moments of magnet will be what? This is we have to calculate. Now frequency is given here. So we know that if time period t equals 2 pi under root I upon mb, then frequency of the oscillation will be written as 1 by 2 pi under root mb divided by I. Now since like poles are tied together, so their magnetic moment will be added, and we can write the frequency f1 in this case, that is 1 by 2 pi under root m1 plus m2 times b, moment of inertia, scalar quantity added every time, I1 plus I2. Now if they are reversed, means unlike poles are tied together, then frequency is f2, 1 by 2 pi under root. Now their magnetic moment are opposite, so they will be subtracted, m1 minus m2. Moment of inertia always added, b. Taking the ratios everyone, let's see what we are going to get. f1 upon f2 equals under root m1 plus m2 divided by m1 minus m2. Squaring both sides, we will get f1 upon f2 square, that is 20 by 5 square equals m1 plus m2 whole divided by m1 minus m2. 20 by 5 square gets you 16 only, cross multiply, you will get 16 m1 minus 16 m2 equals m1 plus m2. You have to calculate the ratio of m1 and m2. It means let us divide by m2 both the sides. What we are going to get, 16 m1 by m2 minus 16 equals m1 by m2 plus 1. And after rearranging and solving, we will get m1 m2 ratio as 17 by 15. And after looking at the options, we can say that option number 2 is absolutely correct. We can go through option number 2. Now let us proceed to the next question, that is question number 32. So here is the question number 32. An aeroplane with wingspan 30 meters flying at 200 meters per second straight south parallel to the Earth's surface. If the Earth's magnetic field has horizontal component of 2 into 10 to the power minus 4 Weber per meter square and 37-degree dip angle, then EMF induced between the tips of wings will be what? From the question, it is very much clear that the vertical component of Earth's magnetic field will provide the induced EMF. So we can write induced EMF E as BV into V into L, where BV is the vertical component of Earth magnetic field, V is the speed of plane, L is length of wing. Now BV we can write BH tan delta, where delta is angle of dip already given in the question, speed 200, length 30. BH given 2 into 10 to the power minus 4 multiplied by tan delta, that is tan 37, 3 by 4 into 200 into 30. After solving this, we will get the value of E as 0.9 volt. And when we look at the option, we can say that option number 1 is absolutely correct. So we will go with option number 1. Now let us proceed to the next question, that is question number 33. In the circuit shown after closing the key, in steady state, mark the word steady state, the reading of emitters A1, A2, A3 and A4 will be what? Now we know very well in steady state, capacitor acts as open circuited and inductor acts as closed circuit or short circuited. So in steady state, capacitor acts as open circuited. Therefore, current across capacitor will be 0, and which gets you the reading of A3, that is IA3, will be 0. Now, during steady state, inductor is short circuited. It means this is short circuited, so that's why all the current coming from the battery through A1 will pass through the inductor. This provides you the reading of A4 as 0. Inductor is short circuited. It means all current passes through A2. Therefore, current across resistor, that is IA4, will be 0. Now, 5 ohm is the net resistance, 10 volt is the net potential difference, so we will get the value of current from the battery, that is I equals 10 by 5, 2 ampere. This 2 ampere will pass through A1 as well as A2. So therefore, IA1 equals IA2 equals 2 ampere. So our answer must be I1, that is 2, 2, 0, 0. And after looking at the options, we can say that option number 3 is absolutely correct. So we will go with option number 3 only. Now let us proceed to the next question, that is question number 34. Here is question number 34. Magnetic field in a plane electromagnetic wave is given by By equals 10 to the power minus 7 Tesla sine 10 to the power 3 pi x plus 2 pi into 10 to the power 11 t j cap. Now looking at the equation, we can say that B naught is 10 to the power minus 7 Tesla. And here you are getting kx plus omega t or omega t plus kx, which says that the electromagnetic wave is traveling in negative x direction. Negative x direction. The magnetic vector is toward j cap. So we know very well the direction of traveling wave is given by E cap cross B cap. Now minus I cap equals E cap, which we have to obtain the direction of electric vector. Suppose it is E cap only multiplied by B cap. B is J cap. So E cross J, you are getting minus I. It means what? If you do J cross K, you will get plus I. You are doing J cross K, you are getting plus I. Now do the vice versa. If you do K cross J, then you will get minus I. It means E cap will be same as K cap. Means the direction of electric vector will be toward positive K cap. Now let us calculate the amplitude of electric vector in order to obtain the equation. What we will get? We know that E naught upon B naught equals speed. Therefore, E naught will be B naught multiplied by speed. B naught already given in the question. What will be the speed? Speed will be omega by k. After looking the equation, you can write omega as well as k. Now putting the values, B naught, that is 10 to the power minus 7 into omega, that is 2 pi into 10 to the power 11 divided by k, that is 10 to the power 3 times pi. After solving, we will get the value of E naught as 20 volt per meter. Now we can write the equation E, which is towards Z. Therefore, Ez equals 20 sine 10 to the power 3 pi x plus 2 pi into 10 to the power 11 times T k cap as electric vector is toward k cap. So after looking at the option, we can say that option number 4 is absolutely correct. So therefore we will go with option number 4. Now let us proceed to the next question, that is question number 35. So here is question number 35. Refractive index of slab R if refracted ray CD parallel to incident ray AB is. Now we have to calculate the refractive index of slab R. Given that AB parallel to CD, we can write according to question, if this angle is I, then surely this angle must also I. Now suppose this is interface number 1, this is interface number 2, and this is interface number 3. For interface number 1, I will be the angle of incidence, R1 will be the angle of refraction. For interface number 2, R1 will be incidence, R2 will be refraction. For interface 3, R2 will be incidence and I will be the angle of refraction. From the diagram it is very much clear. Now let us applying the Snell's law for all these three and multiplying all these three equations, we finally get what? Sine I1 upon sine of R1 multiplied by sine of R1 upon sine of R2 multiplied by sine of R2 upon sine of final angle of incidence, that is I. If you do this, we will get 1. Now sine I1 upon sine R1 will be what? Refractive index of refracting medium divided by refractive index of incident medium. Incident medium is air, refracting medium is 1.45. So we can write 1.45 divided by 1 multiplied by, this is for interface number 2 where refracting medium is 1.5, incident medium is 1.45 multiplied by, for interface 3, refracting medium has refractive index mu suppose, which we have to calculate, incident medium is 1.5 equals 1. Now after solving, we will get the value of mu as 1. It means medium R has refractive index 1. So after looking at the option, we can say that option number 2 is absolutely correct. So we will go with option number 2. Now let us proceed to the next question.